Okay, so good morning and welcome everyone to CppIndia User Group Conference. This community is with C++ as a common interest, and here we can share all our learnings and anything worth sharing with the community. Okay, there are a couple of other ways to connect and contribute to this community. You will get an email with all the information later on this session. Today we have Shilpa here. She will give some detailed insight on Lambda function today, which were introduced in 2011. Shilpa has more than 6 years of software development experience in C++. Currently, she is based in Mumbai and working with Itiviti. We are recording this session, so these recordings will be available after this, and we'll upload these recordings to community YouTube channel. So, and I will share you all the links and everything. Okay, and post this session, we'll share you one feedback form, and we'll be happy to hear from you. Okay, so now without taking any more time, I will pause and hand over to Shilpa. Shilpa, you can share your screen and you can start.
Yeah, hello. Am I audible?
Yes, yes.
Yeah,
Yes,
okay.
Shilpa.
Yeah. Can you guys see my screen?
Yes, we are able to see your screen.
Yeah, I guess. Is the presentation visible now? Just
Yes.
confirming. Yeah.
Yeah,
Okay.
yes.
So today we will be gonna talk about lambdas. So before I start, has anyone ever used lambdas in their code, or have they tried to learn about it?
Yeah, we are using our Lambda in our code.
Okay, okay, cool. So even if you have not used it, to the other participants, we will start from the very basic, and then we will build upon examples to understand about the concept of lambdas. So let me first give you a basic introduction about lambdas. They were introduced in C++ 11 standard, and they allow us to write the unnamed functions in place. What do I mean by that? So let's just say you have a very trivial task, and to achieve that trivial task, you decide to write a function. So you name a function, you write a function, and then you use it. But the task is so trivial that naming the function, defining and creating the function, and then using it is too much for that task. So only if I had the option to write the nameless functions at the place where it is supposed to be used or passed as an argument to the function, it would be very helpful, and that's what lambdas help us to achieve. And from the technical perspective, lambdas are nothing but the syntactic sugar for the function objects, which are also known as functors. So let me first start with what is a function object, since lambdas are nothing but the syntactic sugar for that. So let's start with what is a function object. As the name itself has two words, the function and the object. So if I can make my object behave like a function, I have a function object. But an object of what? I can have an object of a struct, or I can have an object of class, right? Now, if I got the object of a struct or a class, how can I make it behave like a function? So I would have to overload the operator, function call operator. So let's just have a look at this example. First of all, I have, is my cursor visible?
Yeah, we
Yeah.
can
Yes, Shilpa,
see
we
your
can
screen.
see.
Okay, cool. Thank you. So here I have first defined a normal function in the global namespace. Okay, we will come to this. Now for function objects, I will first have to start with a structure. So I have defined a struct A over here, and it has two member functions. One is the normal member function called print, and it accepts one int parameter and just prints it out. And then I have also overloaded the function call operator, which does the exact same thing. For the simplicity of the example, I have kept the bodies of both the functions same. So, in the main function, if if normally I had to call a function, what do? I just write a function name and then I pass the arguments, isn't it? So this is what I have done. I have used the function name and then I am passing some argument. Now, for the function objects, as I said before, I will first have to declare an object. So I'm declaring an object, okay, which we are calling it as small a. Now, normally, if I had to call the member function of this object, what would I do? I would call it using the operator dot. So a dot print and then pass in the arguments. Now, if I had to call this function call operator, I can do it like a dot operator parent parent. So the function name of this function call operator is operator and then open and close parenthesis, and then it accepts some more input arguments. So to call this function, I have to provide two parentheses. One parenthesis belongs to the function name, and then in the another parenthesis, I am passing in the argument. But since this is overloaded, why do we overload the operator? So that we can use the shorthand. So if I have declared my object, if I had overloaded my operator, function call operator for this struct, I can directly use this object as a function. So what will I do? I will just write the name of the object, which we will use it as a function. So I'm passing some arguments to it. Let's have a look at the output of this function. So I'm using GCC compiler, the latest one, and I have used the C++11 standard. And as you can see, at the last line, the compiler has appropriately called the overloaded function call operator. So that means my example works. And if any of you want to try this example, you have to just click. You can see there is some link to it. You can just click on the image and it will redirect it to you, the online compiler. So this was a very trivial example about the function object. Is it clear? And then I can proceed. This was very basic about it.
Yeah, Shilpa.
Yeah, okay. Thank you. So now, why do we need function objects? What normal functions can't do, that we have to have a separate function object as a concept. So as function objects are nothing but the objects of some struct or a class. So, and my class or my structure can have data member variables, right? So if my structure or a class can have data member variables, it can hold state. So that's what makes it different from the normal functions. So let's just have a look at another example where I will show that. So let's say I have a vector of int v which has elements from 1 to 6, and my task is to print each element of this vector. But before printing it, I have to increment it by some amount, and that increment amount will be decided by the user at the runtime. So I can't use my normal function over here because the increment amount is not decided at the compile time. I don't know it. I can't hardcode it in the function or as a global variable. Now, since the increment amount will be decided by the user, I have to hold this state somewhere. And once this state is decided, it is not going to change. Once my increment value is decided, it will not change. So I can use my function object over here. Also, if you look at the problem statement, what I have to do is I have to iterate over the elements of the vector and do something on it. So the for each algorithm of the STL library is perfect for it. It does iterate over the elements of the container and do something, and that something will be provided by me. So to do this increment thing, I have declared the struct add and print, and it has a member variable called m increment. Now, whenever someone creates an object of this add in print, it will have to pass an increment amount. And this increment amount will be used to initialize the m increment. And then to make this object behave like a function, I have overloaded the operator. Now, why do I have to make this object behave like a function? Because the for each algorithm accepts only the function pointer or the function object as the third argument. So as we have already ruled out the function pointer, the normal functions, I have to use a function object. So to in order to make my object behave like a function, I have overloaded it. It will just accept one int parameter, and since I have its state available to me, I'm just directly using it for each x object that will be passed to me. So now I have declared the object over here. I'm passing the increment value, and then once I have declared this object, I'm passing in as the third argument to the for each algorithm. So let's have a look at the output. So I am passing the increment amount as 1 to the program. As my vector elements have 1 to 6, so it will print from 2 to 7. Also, for the demonstration purposes, I have declared a separate object at line number 18. You don't really have to do it. You can directly make an object of a struct and then pass it to the for each algorithm. It will work the same. Now, if I go back to my problem statement, my task was very simple. I have to iterate over the element vector, add some increment amount to it, and then print it out. But to achieve this task, I have to write a structure, then I have to overload the operator, then I have to pass it, and then use it. So the code readability is hampered because from the name of the function or from the name of the object, I can't really understand that is it only just printing or is it actually incrementing and then printing. So what if I had the option, as I stated before, if I had the option to write the nameless function over here and use it as I define it. So that's what lambdas help us to do. And we will go and now we will write this same example with the help of lambda functions. So this is lambda. Okay. So the first thing that strikes is, if you see, there was a lot of boilerplate code in my previous example. Now it has totally removed. I don't have to write a separate structure, overload the operator, and yada yada. So if you will we will look at the lambda syntax in the next slide. But for now, if you will see what my task was, I can directly see at this line. My task was to increment my each element of the vector by some amount and print it. So I can directly see on this line. This is nothing but a function, a normal function. Just ignore the square brackets for now. So you will see this is nothing but a normal function. I have written it in one line. That's it. And since I have to increment the element vector by some amount, so somehow I have to capture the state, because in order to use it in my lambda body, I will have to capture the state. That is, I have to capture the variables that are declared outside the lambda. Otherwise, how will I use it? So that's what square brackets are for. Next, we will look into what are the parts of the lambda expression. But is it clear till now? So I can move it to the next slide.
Yes.
Yeah. Okay. So now we will dissect the lambda expression a bit more. So in the square brackets, we are allowed to capture some variables. Why we need to capture some variables? Because they are declared outside of the lambda function, and I would like to use them inside my lambda body. So that's what capture list help us to do. And we can capture by value and by reference. Okay. So we will look into these examples a bit later. We will look into the whole capture list rules. Then we have the normal function parameters, wherein you will be providing the input parameters. And you can provide as many input parameters as you would normally do for a function. normal function. Then we have the trailing return type, and this is optional. So if I go back to my previous example, you will see I have not provided any I have not provided any return type to the compiler. The compiler is automatically deducing its type. So in the Lambda body, I'm not returning anything. I'm just printing something. So the return type would be void. If I would have used the Lambda function with a sort algorithm, I would have to return the bool value. So if in that Lambda, the compiler will automatically deduce the type as bool. And then we have the normal function body. So that these are just the parts of Lambda expression. If The only extra thing in this Lambda expressions is that captures. We don't have to write the return type as well. Okay. So as I said before, the lambdas are nothing but the syntactic sugar for the function objects. So what does the compiler do if it sees a lambda expression? It generates a function object for the lambda. So how does it do? How the compilers do it? So as I said before, we have something called capture list. So whatever variables I will be capturing in this square brackets, the compiler will generate the member variables for that class, and it will have the same name. At least in C++11 standard, it will have the same name. So when I'm passing my increment variable that is declared outside the lambda function, the compiler will create a data member variable inside this class type, and this type will be decided by the compiler. We don't know it, it's implementation defined. So it has generated one data member variable with the same name called increment, and it will initialize this increment. Sorry, I have used the same names. I should have written m increment to make it more readable. So let's just say it's m increment for now. So now m increment will be initialized with the increment that I have passed in as the constructor. So if my increment value is 1, so m increment will be 1. And also, since I'm capturing it by value, there is no reference to it. So even if the increment value gets changed to 2, it will not be available over here because I have captured it by value. And the whole lambda body directly goes into the void operator function. And this function called operator is by default const. We will also come back to this const thing in our examples. So as I said before, the lambdas are nothing but the syntactic sugar for the function objects. This is what actually compilers do. They generate the function objects for us. Why would I write a function object if I have lambdas with me and I can save my time? So now let's just have a look at some of the examples. I would just click this.
Shilpa,
Yeah,
before we jump into example, I have one question in the
yeah, yeah,
last slide.
yeah.
Yeah, here. Uh, by any chance, is it possible to take this increment as a reference?
Yeah. I will be showing that in the examples. Yeah.
Okay, okay,
In the capture list, we can capture the variables by value and by reference. So we will be looking into that now itself.
okay.
Yeah.
Good.
Okay. In order to show you the difference between capture by value and capture by reference, I will just remove this. And let's just say I have this vector of int which has some elements, and I would like to sum up these elements. So I declare a sum variable in sum variable. Now I would like to use my favorite algorithm for each. Okay, and then I will capture this sum variable inside a lambda. Then I would let me just move it over here. Yeah. And I will simply add keep on adding the vector elements, and then I will print sum. Okay, so I have captured the sum variable and I'm incrementing it. The code looks right to me. Any idea what will happen? Will it compile? Will it not compile? Will it give me some error? Or what will be the output? Okay, so as I said before, the compilers, whenever they see a lambda function, they create a function object for us, and the overloaded function call operator is const. So if this is const, I cannot actually modify its own data member variables. This is what the compiler will give me an error. So it says the assignment of the read-only variable sum. Since the function call overloaded operator is const, I cannot modify it. What if I have to modify it? Then I can write mutable. Now the compiler warning is gone. Trust me, I will show you in a bit. It's gone. But what will happen now? Will the sum will be equal to 21, or will it be equal to 0? Now the compiler is allowing me to change the summation. Okay, so the compiler error has been removed, but the sum is still 0. I'm not able to calculate the sum of the elements in this int variable. To show you the compiler is actually executing this piece of code, I will write inside lambda. I will print what is the sum value inside the lambda.
Shilpa, one question.
Yeah, yeah,
Like,
yeah.
yes, can you just show that compiler error once again?
Yeah, yeah, sure.
What it was?
Yeah. It was saying that it cannot assign the read only variable.
Okay, so what it means?
Okay. Let me show you with this example. So what is happening? This operator, the function call overloaded operator, is const by default. So when I'm
Okay,
saying a member function is const by default, I cannot modify the data member variables of that class, because I'm saying that this function is const. So when I'm saying it is const, I cannot modify. I'm just using the variables. I cannot modify the variables. So
okay,
if I will write increment equals to 2 over here, it will give me the same error.
okay.
Yeah.
Yeah. So that's why you are adding mutable keyword there.
Yep. So if you are capturing something by value and you have to mutate it inside the function, although I don't think it makes sense to capture it by value and then mutate it, because if you have to modify it, you should actually capture it by reference, right?
Yeah,
But this thing is available, so, and what it does, so I'm explaining that.
yeah, that's
So yeah. So I have added the mutable keyword over here. We have got rid of the warning, and inside the lambda function, if you will see that it is actually summing up our vector elements. Why? Now, why is it that inside the lambda I'm able to receive my 21 as the sum, but once my for each algorithm is executed, it is printing 0? Because I have captured my sum variable by value. So it is creating another member variable inside its function object. So if I will show you this, when I am saying that I have captured I'm capturing some variables over here by value. So the compiler is creating another set of data member variables with the same name. So this increment is not the same as this increment that is inside the member function. So if I give you some simple example, let's just say I have int x equals to 1, and then I say int y equals to x, and then I increment my x to 2. So will my y will be changed? No, it won't be changed because I'm copying it by value. Why will it change? Isn't it?
Right.
This same concept is applied over here. I'm capturing it by value. That means I'm making a copy of that state into my function object. So let me just get rid of this. So this is the reason why inside the lambda body I can see my summation is getting incremented, but once the for each algorithm gets executed, I'm still with I'm still with 0 in this sum variable that was declared outside the lambda function. This is where I can actually tell you that if you will capture it by reference, I will get rid of mutable thing, and I will also get rid of this. Okay, let's keep it. So now when I'm passing it by a reference, when the lambda body is executing this statement, it is actually modifying this value. And when it is modifying this value, once this function is completed, I will still have the 21 in my sum variable. So inside the lambda, it is incrementing, and now my sum is actually 21. So this is the main difference between capture by value and capture by reference. Uh, any doubt? Because this is the main basic. Everything after this will be just a build up on this by value and by reference thing.
Shilpa, one doubt I have, means
Yeah, yeah,
maybe you are going to cover in future in next slides.
yeah,
My question is, like the sum is a value which is in a global, means a global scope or somewhere, means
yep,
it's also a variable, right?
yep, yep,
And this int x, this is also a parameter,
yep.
right? So what is the difference? Means why can't I use this sum here, and why we have this?
You mean to say why I'm capturing it over here and why I am not passing it as a argument?
Yes, yes, means what difference it will make if
Yeah.
you can.
So, from technical perspective, the for each algorithm will only accept a unary function object. So it can only have one parameter in its um in the lambda body function. I can so even if I write a normal function, I will have to write a function that only takes one parameter because that's how for each algorithm is. Now, to answer your question, um, when I would say this lambda body, I have to reuse it for some elements, and I have to store and uh, mm, just a sec.
Yeah.
I the reason why lambdas are preferred over the functions is that if I were to use a normal function, okay, I will have to pass two arguments to it, right? Int x and int sum. Let's say just keeping the same variable names, int x and int sum. But my sum object isn't really changing. I have a state, right? The only
Hmm.
thing that is changing is my vector elements. I'm iterating over it.
Okay.
Yeah. So I can save this state. So if my variables aren't changing, I can save that state. I can capture it my capture list. And whatever variable arguments I have, I can capture it in a function parameter. Does that answer your question or
Yeah, so can I say, means in a capture list, I should take those things which are not going to change inside a function. And
Yeah, which are not going to which are not going to change inside the function, and also which you are not accepting as the input parameter. So in my case, I'm not accepting my sum as the input parameter.
okay, okay, yeah, that's
Yeah,
okay. Yeah.
yeah, yeah. So this was about capture by value and capture by reference. Now you can also mix and match these capture variables. Some of the variables can be captured by value, and some of the variables can be captured by reference. Now, if I declare one more y variable with the value 1, and if I capture it like this, so I'm capturing my y value with capture by value thing, and I'm still capturing my sum because I have to modify it with reference. Now, you can do the same. Like there is no rule that first reference variable has to come and then by value variable has to come. You can actually mix and match in any way. Now, we have something called shortcut for the default captures. So let's say if I have to, whatever uh, variables that are declared outside the lambda function and I have to use them inside it, I have to capture all the variables by value. Oh, sorry, by reference. So in my example, I'm not using y over here. Let's just print y so that I'm using it. And I just write it as ampersand. So this, what this thing instructs the compiler is that whatever variables I am using inside the lambda function, so I'm using sum and I'm using y, capture it by reference. Okay, so if I will, okay, yeah, the I have initialized the y with 1 and I'm not really doing anything, so it will print 111 and my sum is still getting printed as 21 because I have passed all the variables by reference. Okay, so now if I remove this line, so that means I am, sorry, that means I'm not using y anymore. So what will happen is the compiler will not capture the y variable because I'm not using it. Although it has been declared in the same scope in as the lambda, if I'm not using it, why should I capture it? If I'm using something, only then and only then the compiler will capture it. The same goes for uh, by value. So this is the shortcut for capturing the variables by value. All the variables that will be used inside the lambda body will be captured by value. So if I'm capturing it by value and I have not used the immutable keyword, I will get the compiler error. And if I use the mutable keyword, I will get the summation as 0 because I'm actually modifying the member variable of this lambda function and I'm not actually modifying this thing. So this is about capture list. We have some more concepts related to capture list. So let's okay, before I proceed to the capture list once again, I just want to remind you that you can actually capture the lambda function in a variable. So, and your capture list can be empty because I'm not interested in capturing anything. So capturing I'm not capturing anything. I'm not accepting any input parameters and I'm not executing anything. So this is, I have declared this is a valid C++ code and I have declared it, and I have declared a lambda function over here and I would like to capture it. So I can capture it in a variable just like we normally do. Now I have used the keyword auto over here. Why? The reason being, this is a nameless function for me. I don't know the type of this lambda. The compiler will generate a type for me. And since the compiler will generate a type for me, only compiler knows what the type is. And hence I will have to use the lambda over here. So uh, if I just execute this lambda, okay, I will write some statements to show you that it does execute. Okay, so it's printing. So I have uh, defined my lambda function over here. I have captured it, and then I have normally called this function. The reason why some people prefer this is that they don't like to write the lambdas in place the way we have used it in our for each algorithm. Some people would like to name it, although it kind of contradicts with the lambda definition that if you want to write the nameless function, but yeah, you can definitely do that. You can capture the variable and then you can execute it. This is especially useful in callbacks. So if I sorry, I'm going a bit off topic, so but it will be helpful to understand why we need to capture the lambda.
So, Shilpa,
Yeah,
one thing here. So,
yeah,
means in this statement, what you wrote, it is
yeah,
same like a normal function, right? Means if I write
yeah,
a normal, it will
yeah.
be it means these two are same.
Yeah, these two are same exactly. But for a normal function, I would have to write it over here, and then
Hmm.
I will be using it in the main function. So if I have if I'm working with a piece of code with 1000 lines of code, okay,
Hmm.
and I have to do something very trivial, like let's just say I have to print something. I have to print my vector or anything. So what I will have to do, I will have to write a function maybe at the top of the file, and then I will be using it at the very bottom or in the middle of the file. So the function is not doing anything as such. It is just doing very simple job of printing. Correct.
Yeah, yeah, right.
So if I have to do some very trivial job and it can be done, and if you would like to get it done then and there, like define it and then use it, the lambdas are apt for it.
Okay, okay. Yeah. And what
Yeah.
about that callback thing you were talking?
Yeah. So uh, sometimes you get a callback. Let's say, okay, you get a callback for an object. Now you have to perform some modifications on that object, but only if so let's say you have to perform two modifications on that object, one after the other. But the second modification can happen only if the first modification has happened. Okay. So if I get a callback, I'm just randomly throwing. This will not compile to just to explain the concept.
Yes, yes.
So if I get some order, and I have to perform some operations on it. So I have to perform operation 1, and then I have to perform operation 2. Let's just say, for the sake of example, I have to perform increment in this operation, and I have to also um, uh, increment the same variable in this operation. Okay. But the thing is, I cannot do it consecutively. Maybe I am waiting for something. So let's say I have incremented my variable, I have set something for the order, and then when I'm setting something, it will generate some other callbacks for different objects. Okay.
Hmm. Yep.
Yep. So I have done some operation, and then I'm waiting for another callback. And once I have received that another callback, let's say handle trade update, I have to perform this other operation. So if I give you some example. So, so when I increment my variable over here, a trade gets generated, and once I receive the trade generated, I have to update in my order some more parameters. Okay, so I can write a lambda function over here and store it in a container. And then when I receive the handle trade update, because the thing is, why would I want to write a lambda function over here? Because I'm getting my order object in this callback only. I'm not getting my I'm not getting the order object once again in this callback. I'm only getting my trade object.
Right.
Yeah. So I'm storing. So in this in this scenario, I will define a lambda which will capture my order, and then I will store it inside a container that I have to perform so and so operation. So once I receive my trade object, and it will obviously have the order identifier. So that is why I would be able to call back this thing to execute my lambda function. So basically, lambdas actually can be used, are very useful when you have asynchronous callbacks in your system.
Okay.
Yeah.
Silpa, just one request. Maybe you don't have any working code right now. So
Yeah.
after this session, can you share one working code of this concept just for
Yeah, yeah.
reference? Yeah.
Yeah,
After this
I
session,
was
you can.
actually trying to do with simple class and trying to simulate this example, but
Mhm.
I did not actually get the time to show you the
Okay. Okay. No
some
problem.
real code. Yeah,
Yeah. Yeah. No problem.
yeah.
We got the concept. Just if after this session, if you get some time, you share this code. That
Yeah,
would
yeah,
be
yeah. I
great.
yeah. Actually, we use it in our system actually. So
Mhm.
I won't be able to share the exact code, but I can
No,
share
no.
the what we try to do with some
Yeah, just a dummy
normal
code
C++.
because this is the thing which in actual systems which will be very useful.
Yep, yep. It is very useful. But
Yeah.
the thing is, in that scenario, the lambdas can be a bit expensive. Just so let you know, because I'm storing it in a container, right? Let's say I'm just storing
Yeah.
it in a vector. So
Mhm.
the way to store a lambda in a vector is with the help of std function. So we have something called function wrapper.
Mhm. Right.
So I will share you the details for that.
Yeah, yeah, yeah. After that, you share. Now you
Yep.
continue.
Yep.
Thank you.
So yeah, this was about capture list. Uh, um, there's one more. There's one last concept related to the capture list. Uh, let's say I have a class A. Okay. Let's just say it's struct. I don't have to write public and private every time. So it has a member variable, and I will just default initialize it to 5. Now I have a print function, and inside this print function, if I try to access member variable, okay, so I will be able to use it, right? If I declare my function object over here and I called print, it will print mem is 5. Okay, sorry, my bad. It will print mem is 5. So what if I had to declare some lambda function inside this member variable, member function? So let's do it. I'm using the lambda variable. I am not capturing anything. I am not accepting anything. And I will just move this thing over here. And so I have defined my lambda and captured it into a lambda variable, right? And now I will call this. Okay, it will give me a compiler error. It will say that this was not captured for this lambda function. Okay, so the reason is that, oh, okay, let's, since I'm using a variable outside of the lambda function, this is not declared, this is declared outside the lambda function, let me pass it. Okay, so ideally it should capture it and then it should be able to print, but it gives me some more errors. It is saying that it cannot capture, this was not captured, this is invalid use, yada yada. So what is actually happening is, inside this capture list we can capture only the variables that are local to the function anywhere, whether it's a normal function or whether it's a member function. When you're trying to capture something, that variable has to be local to that function. So just to prove my point, I will declare one extra variable m, and I will pass it and I will print it. It's compiling, yeah. So now I can use it. So the thing is, I can capture only the local variables. I am not able to capture the data member variables, even though I am writing this lambda function inside a member function. Ideally, I should be able to use it, because when I had written my cout statement outside over here, I was able to use my member function. So in order to capture my member variables, data member variables, I will have to pass the this pointer to this member function. The data member variables are hidden behind the this pointer. And if you know about the this pointer, every member function gets this pointer as the hidden parameter. Compiler automatically does it for us. So when I am capturing this pointer, this is a pointer, it's a reference to this object. So when I'm capturing this object, the compiler knows, okay, now when I'm asking it to print the member variable, it is asking about this object, and which has a data member variable called mem. So if this is a little on the top kind of thing, but yeah, if if as a simple rule you have to remember it. So if you are defining a lambda function and using it inside a member function, you will have to pass the this pointer in order to
Uh,
use its member variables.
yeah, Shilpa, is it possible that I pass this as a parameter instead of capture list? What will happen? Can we try this?
Yeah, sure, we can try it. So basically you are saying, I will pass, let's say by reference, okay,
Yeah, yeah.
and then I am doing it by this, and then I would have to pass, since I am taking a reference of it, I will have to pass star of this. I can, this is a pointer, so if I have to keep the example same, I will just do it like this, right? Let's just see. Yep, it's working.
Okay.
But the point about lambdas is that like you can capture the variables, you don't have to pass it again and again.
Hmm.
So
Right.
yeah, so if I have, let's say, vector of these many objects, so I will have to pass this object again and again.
Yes, right. Right.
Yep, yep. But yeah,
And
but this is working, yeah.
yeah, and about capture list,
Ye-
can I say we can capture all the variables in the enclosing scope?
in the
Means-
enclosing scope, uh,
Yeah, means whatever
only,
this print function means in this
hmm,
scope, this lambda was lambda
yep,
we declared. So
yep.
whatever variables we have in this scope, those we can access directly. Like
Yep, we can access directly, but the thing is, if you are not using a variable, it will not be captured. If if I just go back to my previous example, ठीक है.
Yeah.
And I instruct the compiler to capture all the variables by reference. Okay.
Mhm.
But I am actually not using my x and y. I'm not using it
Yes, yes, then it will not exist. That's right.
no.
Means
Yeah.
I was talking about this mem variable, mem member variable.
Yeah.
The example you showed,
Yeah.
that
Yeah.
example means that was perfectly fine. I
Yeah.
was just trying to summarize that line. Uh, Miss, can I say, Miss, if this mem is in the scope of this print, then we can
Hmm.
access that. But if that variable is not in that enclosing scope, we cannot access that.
The yeah,
Means
you are
without this,
correct. But
without this pointer.
without this pointer, you cannot access it.
Yes, that's what I wanted to. Means if I
Yeah. Yeah.
move this int mem equals to 5 inside this print function, then I can use it, right?
Yeah. 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 Yeah.
Yeah.
Yeah. And one more thing is, here I'm showing only with one variable. So if you had some five more variables and you are passing this pointer, then you will be able to access all the member variables, mem1 to
Okay.
mem5, because you are passing a reference to the whole object. So when you have a reference to the whole object, you can access anything that is public.
Okay. Anything that which is public,
Yeah, public.
not private.
Yeah, no, no. In case of member functions, yes, you can access private member variables as well. Yeah,
Okay. Okay.
yeah, yeah.
Okay. Yeah. Fine.
Yep. So this was the last thing about the capture list. Let me just go back to my previous slide. So we have capture list. We have no captures, wherein you don't capture anything, and this will be especially useful if you are writing some lambda function for a sort. Then we have by value, and we have by reference. Yeah, we need to be careful about dangling references. Okay, what do I mean by that? I will just show you an example, but for that I will have to bump up my standard to 14. Why, I will tell you. So let me just give you an example of dangling reference. So I am writing a normal function over here. Okay, and I'm instructing the compiler to deduce the type of it. Okay, so I have initialized my x with 0, and what I will do, I will return a lambda from this function. Okay, now when I'm returning the lambda for the function, I'm capturing my local variable. Since this is a local variable, I can capture it, right? And I'm capturing it by reference. And I will print my x. Okay. And since I am returning a lambda function, I don't know the type for it. I will write a auto over here. Now in C++11, it doesn't allow you to write auto in as the written type for a normal function. Then you will have to use the function wrapper and all that. But that's not what I am trying to uh, portray over here. So let's just say I have declared a normal function. I have declared an int variable called x, and I'm capturing that x by reference and I'm printing it. Now I want to call this lambda. Okay, lambda function. I have called this lambda function. Now this lambda, normal lambda function is returning a lambda, and I would like to execute that lambda. So I will have to write one more operator parenthesis and then colon. Is it understood? Did you understand why I have written two parentheses? This is my
Uh,
yeah,
this lambda function
yeah,
at line number 7, it
yeah.
is returning a function,
It is returning a lambda.
lambda function. So
Yep.
to call this returning function, you added this second
Yeah,
parenthesis, right?
yeah, yeah, yeah. Correct. Okay. So if I will, this code will compile. Okay. The compiler will not give you any error. Okay, I have missed some colon. Now, if you see, I have initialized my x with 0, but I am getting some 32766, and if I will run it again, it might give me some different numbers. If you will keep on running, it will give you some different numbers because I have captured a dangling reference. Once this lambda body has executed, this x no longer exists on the stack. Correct? This is no longer a variable. This doesn't even exist. And I have captured a reference to it. So this is undefined behavior. So when you are capturing the references, you will have to be very careful that and you will have to be very careful about when the lambda will actually execute, that object should actually exist. It should not destroy itself. Okay?
Yeah.
Yeah. So, yeah, this was the thing about references. So, you will have to be very careful. Then, this especially comes into picture when we have callback scenarios. Because if I am declaring some local variable and then passing it to a lambda function, and that lambda will be executed in some other callback, that local variable does not exist. Then we have seen the shortcut for all value captures. So if you have to capture all the variables that are used inside the lambda function by value, you can do so by using the equal to sign. Same goes for reference captures. And we can also mix and match reference and the variables. And we have also seen about the diff pointer. So this was all about the capture list. The capture list is the only thing that makes the lambda function different from the normal functions, because the rest of the body, rest of the input parameters are as similar to a normal function as it can be. Okay, so then we move on to some enhancements that were introduced in C++ 14 standard. One of the enhancements that I have shown you that for a normal function, you can use auto. So uh, the compiler will automatically deduce the type for the return. So if I'm not returning um, lambda function, if I'm just returning a bool or int, the compiler will automatically deduce it. So this was for normal function. They have done the same for a lambda as well. So now the lambda can take in the input parameters, right? But if I go back to my previous example, the increment example, I was specifically accepting an int parameter. What if I have the vector of double? So I would have to write a special lambda function for it. It is doing the same job. It is printing, it is incrementing, and it is printing. But just because of the type, I have to write one more lambda function. So if I would just pass in the auto as the type parameter, the compiler will automatically deduce the incoming input parameter. So if I will write this lambda print and capture it in a variable, and I have vector of int and I have vector of double, and I just have to print these elements. I have to do nothing else. Here I have shown with actually pair of int and pair of double, but basically you can use the same lambda function if the underlying data type changes and if it supports the output operator or stream operator. So, and the way the compiler does it is with the help of templates. So if the function call operator, the overloaded function call operator is templated, since it is templated, it can reduce the incoming parameter type. Then this was for auto keyword. Then we can also introduce new local variables in the capture list. So in my previous example, I was not able to capture the mem variable directly, right? Let me just go back to it. Yep. Okay. So let's say if I don't have to capture the this pointer, I have to capture only this variable, correct? So I will have to write I will have to copy uh, in this print function. I will have to make a copy of the member function in this new variable called m. Then I will have to pass it, and then I will have to print it. Okay. So the thing is, I have to specifically write this statement. I'm not able to introduce some new data member variables for my function object. I don't want my function object to have the same name as what I'm passing. So in C++14, I can actually use this same line over here. So what I'm doing is I'm capturing mem, and I am giving it a new variable. Okay, and I don't have to provide the auto keyword. So this is how you capture a variable with the new name, and this is only in C++14. Let's just see. Yeah, it's working. Okay, so you can introduce new arbitrary variables in the capture list, and you can also use this lambda, this new arbitrary variable, to assign some new value to an int. In this example, int. So let's just say I have to assign some value to z, but it's a little complicated. It's not straight. So what I have done is I have some int variable called x. Then when I have to uh, uh, when I have to use this x, it is actually x plus 1. I have to use it as x plus 1. I don't have to directly use it as x. So I will introduce one new data member variable for the function object called y, and I will initialize it to x plus 1. And then I'm using this y, then I will just in whatever addition I have to do. In this case, I am doing just y plus 2, and then I'm returning it. Now I have declared the function, the lambda function over here. I have not yet executed it. So it will give you a compiler error. So in order to invoke this lambda and actually initialize my z with some value, I have to invoke it using the parenthesis. So when you will uh, print the value of the z, it will have 7 in it. So these were some enhancements in C++14, and they are actually very good. Like, you don't have to specify the input parameters, and you can actually initialize new local variables in the Lambda object. Um Coming to the conclusion remarks, uh, you should use lambdas to make your code more readable. Like, if you don't have to write a full class, and you don't have to write an appropriate name for the class, and uh, what it does is basically it improves the code readability. You don't have to define the function somewhere else and use it somewhere else. Also, after the introduction of lambdas, the STL algorithms were very easy to use. You don't have to write a function object by hand and then use it. So the STL algorithms and lambdas work really great together. One more caution is that sometimes we like a feature so much that we over abuse it. But if your lambda is doing something more than a trivial thing, like if it has more lines of code than it should, then it's probably better to have a separate function and have a separate name for the same. Lambdas should be used only if you're trying to do some trivial thing. That's it.
Okay.
Any,
Yeah.
yeah,
Any questions? You can ask questions to Shilpa now.
yep. I will be sharing the slides with the these, right? We will be able to share the slides, right?
Yes, yes. You share this slide with me. I will upload on community GitHub account repository, and we'll share
Yeah,
that link with
yeah,
everyone.
yeah. So if you want to try any of the examples, just hit a click the image, and you will be redirected to the link, and then you can uh, do practice some more.
Yeah. So, any questions? Yogesh, Vatsank, Kaneshwar.
Nothing, Dheeraj. I think I can understand some little.
Okay, then I think it is very clear to everyone. Thank you, Silpa, for this wonderful presentation.
Thank you, Dheeraj, for the opportunity.
Yeah, and thank you everyone for joining this session, and hope you all enjoyed and you are getting something valuable today. After this session, I will share one feedback form, and I am expecting that everyone please fill that form. It will help us to know how the presentation was and how the things went. Whether
Yeah, please do give the feedback because that will actually help us to know whether uh, what we should do, what we should improve, and if it's
uh,
something right, then we should keep on doing that.
so I also shared that form link in chat window, so you guys can fill that feedback form and please provide us your inputs how we can do better. Okay, yeah,
Okay.
that's all for today. So have a good weekend.
Yep.
Okay.